All right, we are finishing up chapter 1. We are going to be looking at the states of matter and chemical and physical changes. Remember last time we looked at the composition of matter, and now we're just going to look at the states really briefly to finish up this chapter. All right, states of matter, this is something that you have learned over and over in science classes throughout your elementary and middle school years. And we'll just talk really briefly about them. You can see the Erlenmeyer flask here. Inside them, you can see the molecules of a solid, liquid, and gas. Take a second. How are they different? Okay, so here's some questions that we should be able to answer. Which one, solid, liquid, or gas, has high interactions between the molecules? To have high interactions, they need to be close to each other. The closer those different molecules are, the more they're able to interact with each other. You can see in that solid phase, they're really structured, lined up very tightly. They have high interactions. Which one then has the lowest interactions? In the gas phase, molecules are moving very quickly and they're spread apart from each other. You can kind of see that depicted in the picture there on the far right in the gas phase. So low interactions between the molecules, and then the liquids would be in between. They're closer than the gas phase, but not as close and stacked as the solid phase. Then which one would be most compressible? Well, in order to compress something, okay, it has to have some room between those molecules. The less room it has, it's already pretty compressed. So this one would be the gas phase, most compressible. Most dense, okay, density, how much mass per volume. Okay, the one that is the tightliest packed would have more molecules per volume. Okay, so that would be most dense. When you have a solid, it does not take the shape of the container, stays as it is. A liquid will take the shape. And then the gas phase not only will take whatever shape of the container, but it also fills the whole volume. Okay, so these are kind of the thinking, solid, liquid, gas. In your head, I also want you to start thinking about what the molecules look like in a solid, liquid, and gas as well. All right, so phase changes then are when you go between those states. Okay, those three states that are the basic ones that we talked about in this class, the solid, liquid, and gas. And these can be converted without, keyword there, changing the composition, okay, the chemical composition. You change how they're interacting with each other, but chemically you're not changing what you have. So for example here is water, okay, its formula is H2O. As a solid, it can then convert to a liquid, okay, so you have H2O liquid, and then it can also convert to a gas, and it can go back, liquid, solid, back and forth between these different phases. Notice, okay, the chemical composition of water is the same. It's H2O in all of those different states, okay? So a couple things you want to make sure you know, okay, as you go from a solid to a liquid, that's called melting. And then as you go from a liquid to a gas, that's called vaporization. And if you just kind of skip that middle step of the liquid and go from a solid right to a gas, there's some things that do that, that's called sublimation. To go from that way, solid to liquid to gas, it takes energy. You have to put energy into that. So opposite then to that, if you start at the gas and go down to a liquid, that's called condensation. And then from a liquid to a solid, freezing. And if you skip that middle step of the liquid again, deposition. So going from a gas all the way down to a solid. So energy has to be removed in those cases. And then opposite, going the other way, energy is needed. So again, you can see those structures in the middle there. You can see the solids, those atoms or the molecules there are very tightly packed together. The liquid spread out a little bit. Gas, even less interaction between the different molecules. Kind of get that in your head, how things are working here. All right, so physical changes. These changes will affect the state like we just talked about, but don't change the chemical composition. Here's just some examples. A lot of these end up being food examples. Putting some water in a pot, taking it from a liquid, boiling it off to a gas phase, melting things, even shredding cheese, okay? These are just physical changes. It doesn't change the composition. Physical properties then, okay, are the properties that can be measured without changing the composition. So here are some examples of the properties that you can measure about a substance, and you learn information about it, but the composition of that doesn't change. So temperature, pressure, okay, the mass, you can weigh it and figure out that information. Those are all physical properties. Melting, boiling point, we talked about those. Those are part of those phase changes. A density of an object, its volume, its state, okay. Also things, just some qualitative things like what color it is or the shape of the crystals. Those would all be physical properties. Let's move on to the chemical side. So chemical changes, this is kind of an important thing just to kind of set us up for the rest of this course. We have to understand how reactants turn into products. Okay, so here is just a really great example. If you take sodium metal and add some chlorine gas in, they will react. The sodium and the chlorine gas are both reactants. You can see they're in green there, and they're on the left-hand side of this equation. This equation is showing us the reaction that takes place. Then you can see an arrow, and this says that we're going to turn this into, okay, so if you see a chemical equation where you have reactants and a different something on the other side, that's called your product, and that should let you know you have a chemical change going on. All right, so the products are on the right-hand side. You can see when sodium and chlorine are added together, you produce sodium chloride. Now this reaction gives off energy, okay, it gives off the energy in the form of light. You can kind of see that in the middle flash there, and also heat would be given off for this one. Another important thing is the reactants have specific properties, okay, so sodium is kind of a pretty reactive metal itself. It reacts with water pretty vigorously, okay, so you do not want to just play and touch with sodium, okay, it's not a metal that you just can hold in your hands. Chlorine gas, if you're exposed to that, it's pretty poisonous, can be deadly. Those two things separately have their own specific properties. Reaction takes place, you make sodium chloride. This is also known as table salt, which we do eat, okay, so it has different properties than the two reactants that it came from. Another thing to note, we start with sodium and chlorine on the reactant side. On the product side, we have sodium chloride, but now they're combined together. So we had broken some bonds and formed some new bonds for this reaction to take place. All right, other things, again, a lot of chemistry, kitchen chemistry in here. Other chemical changes, when you see things changing form, a reaction takes place. So browning, color changes are often indicative of a chemical change. Okay, bacon and egg, you're doing something with the proteins there. S'mores, okay, lots of things going rotten. These are all changing from one substance to another. These are not really reversible. Okay, once your banana goes brown, you're not going to get a fresh banana. There was some reaction that took place with the sugars within there that you cannot alter now. All right, so then chemical properties. These are properties that describe how that reactant reacts chemically. Okay, so it's reactivity, or the type of bonds that it often forms, or how toxic it is, flammability, if it's flammable. Those are all talking about chemical changes that take place. So enthalpy, heat of combustion, how stable it is. When you're talking about how something reacts, that would be a chemical property. All right, that is it for chapter 1. These are the learning goals right here that you see that we've talked about in all the different videos for chapter 1. The reason I put these at the end is just so that you have them to kind of use now as a guide, as a study guide really, to go back and test yourself. Do I remember this material? And if not, go back to the lecture notes and read in your book to make sure that you have it all figured out. We'll start chapter 2 next.